dimensional analysis is used to check mathematical relations for the consistency of their dimension. If we have one equation, we will check the mathematical relations in the equation. Either the dimension in the equation is consistent or not. Okay, we will look at example 1. There are two equations here, which is x equal half vt and x equal half vt square, where x is the distance, v is speed, and t is time. The question is, which one is the correct equation? Okay, we look at the first equation, which is x equal half vt square, and use the concept of dimensional analysis. Either the equation is correct, to know either the equation is correct or not. Okay, we will check both sides of the equation. We look at the left-hand side first. Okay, the left-hand side, only one symbol here, which is x. Okay, dimension of x. Remember, the symbol for dimension is a square bracket. Okay, if you write the square bracket, it means dimension. Okay, so dimension of x equal L because x is a distance, so dimension of distance is L, capital L, it's a length. Okay, for the right hand side, there are three symbols here, which is half as a constant, v and t. Okay, so we will check dimension of half, dimension of v, and dimension of t. Okay, so dimension of half, because half is a constant, all constant value has dimension of 1. Okay, dimension of v here is a speed, so speed is a distance over time, so it will be L over t, length over time. So dimension of time is capital T. We can cancel the t and we will obtain the right hand side is L. So now the left hand side is equal to the right hand side, which is L. Okay, we write dimension to both sides, so L equal L, the left hand side equal right hand side. Both sides have same dimension, means the equation is homogeneous and the equation is dimensionally correct. Now for the second example, x equal half vt square. The equation is same like the first one, but the right hand side have t square. So we can repeat the same step. The left hand side, only one symbol, dimension of x, so dimension of x is L. For the right hand side, we have dimension of half, dimension of v, and dimension of t square. So dimension of half is 1 because it is a constant value. Dimension of speed is L over t, and dimension of t square is t square. Okay, we can cancel the only one t, right? So the right hand side has dimension LT. Okay, so write dimension to both sides. Does L equal LT? The left hand side is not equal to the right hand side. Both sides have different dimensions, means the equation is not homogeneous and the equation is dimensionally wrong. For the second example, you can also refer to your tutorial book, question number 6A. So there is one equation which is v equal u plus at, where v and u are velocities, a is acceleration, and t is time. The question is the equation is dimensionally correct? To know either this equation is dimensionally correct or not, we will use the concept of dimensional analysis. If you look at this equation, the right hand side of the equation have two terms, which are u and at. Means the equation has three terms. So this equation is dimensionally correct if all the three terms have the same dimension. So we check the left-hand side of the formula. The left-hand side to only one term, which is v. Dimension of v is LT negative 1. We have done this in the previous example. For the right-hand side, we check the first term, which is u. U is the velocity, so dimension of velocity is LT negative 1. For the second term in the right hand side, which is acceleration times time. Dimension of acceleration is dimension of v over dimension of time. So, dimension of velocity is LT negative 1. And then we divide with dimension of time, which is time. So, it means that dimension of acceleration is LT negative 2. So, dimension of acceleration is LT negative 2 and times time, dimension of time is capital T. So, we made this multiplication. So, LT negative 2 times T, we will get T negative 1, LT negative 1. Now you look at these three terms have the same dimension. Thus, the left-hand side equal to the right-hand side. So both sides have same dimension, means the equation is homogeneous and the equation is dimensionally correct.